All right. Well, welcome back. Um, I'm going to be doing two problems associated with the mean value theorem. The first is identifying or trying to figure out, can we actually use the mean value theorem, or can it be applied? This is problem 8 in a book, in Larson's calculus text. But what it asks is, can the mean value theorem be applied to this problem, where f of x equals 1 over x squared on the interval from -2 to 1. Now, the mean value theorem, a lot of students recognize it as this: f prime of c equals f of b minus f of a over b minus a. Now, according to the mean value theorem, this is basically saying where the secant slope, or secant line slope, is equal to a tangent slope. All right, and that's what we're looking for, where a secant slope will be parallel to a tangent line slope. Now, in order to use the mean value theorem, there are some things that have to be in place in order to do it. The first off is, like any value theorem, the function f of x needs to be continuous, closed, and also, in this case, differentiable on the interval from a to b. Okay. Now, in differentiable, it can just be an open interval. That's what we have. Now, in this problem, so that's what we're going to try to figure out. In order to do this is what it basically is asking. Can we find, or will there be, are we guaranteed a value if I start here at -2, where this point is, and I draw a line to 1, and 1 roughly would be right there. I draw this line, and here's my secant line. Will I find a tangent line that will be parallel to that on that interval somewhere? Now, if it is continuous, closed, and differentiable on the interval, then yes, you are guaranteed, according to the mean value, to do that. Now, the problem with this problem is that this function, 1 over x squared, has x squared at the bottom. That means this function is discontinuous on the interval, or at x equaling 0. Correct? Because that's when that equals 0. And that's where we see this vertical asymptote here on a graph right there. And that's, we have x equaling 0. That's our vertical asymptote. And now we look at our interval, -2 to 1, and we see that 0 is smack dab right in the middle of that. Well, because it's smack dab right in the middle of it, that means it's discontinuous there. Because it's not continuous on the interval from a to b, the answer is, can the mean value theorem be applied? The answer is no. It cannot be applied. Why? Because no, the mean value theorem, MVT, cannot be applied. Cannot be applied. Oops, can't spell. Applied. Because it is not continuous on the interval. F of x is, and I'm writing this very poorly, I apologize, because f of x is not continuous on the interval a to b. All right, or on that open interval, I probably should put open interval a to b. Okay, and that's the reason why. All right, well, that's cool. That's how you can identify if you can use the mean value theorem. So these three things have to be true: continuous, closed, and differentiable on that open interval from a to b. Well, let's look at another problem, number 10, where it says that use the mean value theorem. So we're already assuming that it is continuous, differentiable, and closed on this interval from 1 to 4. And I drew a little, and I put on my grapher, and I put this, my TI, and I have this graph of our function 1 over x. Now, I only highlighted or zoomed in on the part from 1 to 4. Okay? So what we're doing, essentially, is it asks us to use the mean value theorem and find the value where it works. Find the value of c. I don't like those problems because it pretty much just tells you to do something, but we'll do it anyway. So right here, this is what essentially it's asking us to do, is the mean value theorem says f prime of c, okay, equals f of b minus f of a, in this case, because f is our function, all right, b minus a. So find the slope of the secant line, starting at 1, so we have that one right there, going all the way to 4, and if I draw a line, connecting this one to this one right here, okay, we are finding that slope. Move this a little bit better, and we have that slope. Now, this is a ray, but not a line. Okay, so we're trying to find out where will we have basically a tangent line that's parallel to this. And it is guaranteed, and if I actually clone this one, I can identify somewhere right here, if you are good, that yes, these two lines will be somewhere that appears right there. Okay, so somewhere around 2, we can estimate that by looking at our graph. Somewhere right there, that is where C is going to be. It appears from our estimation. Okay, so let's find that analytically. So let's first find the slope we're looking for. So I'm going to plug in f of 4 and minus from f of 1 over 4 minus 1. So let's find this slope first, and then we'll also find f prime of c. So f prime is going to be, we can change that to x to the negative first. So it'll be negative 1 over, in this case, c squared. All right, c being our x. So we're just changing this x into c. And we have negative 1 over c squared, because f prime of x equals negative 1 over x squared. And so I just plugged in c into there. Okay? That's c. All right, now, from here, let's continue on. I plug in 4, and I'll have 1/4 minus 1 over 3. This right here is going to turn out to be, we got 4 over 4. So that's going to be negative 3/4, I believe, times 1/3. Cancel. And we have negative 1/4. And that's going to equal negative 1 over c squared. All right. Well, now let's solve for c. That's our goal. We want to figure out where this value is going to be. So solve for c. When we do that, we can cross multiply because we have two ratios. We have a negative that cancel out. So we have c squared equals, all right, 4. C is going to equal plus or minus 2 because we take the square root. But now we look over here and we identify, well, I only have a value right here on this interval. So we are not using positive and negative 2. We are only using positive 2. And with that, that is where our answer is going to lie, at 2. So actually, I can move this, and it should be right there at 2, and that's where my tangent line is when c equals 2. All right, we got that. If I want to find that equation of a tangent line, I can find out why my slope is negative 1/4. I have my x minus 2. I can find my y value by plugging in 2 into there, so it's 1/2, and that's my equation of that tangent line right there. I'll make it, and there it is. I went above and beyond that, but right there, that is how we can use the mean value theorem. We're using the mean value theorem because we're taking a secant slope and setting it equal to a tangent slope, and we want to figure out where is the secant parallel to this tangent by making the slopes equal to each other. Remember, derivatives are slopes. That's how we can do it. So that's the mean value theorem. Hope that helped, and we'll see you next time in the next tutorial.